Hi guys, continuing from where we left, this is Sejoj. I hope I find you all well. Now, Grade 12 Mathematics Sequences and Series, lesson number 2. Now, in the previous lesson, we looked at what are sequences and series and listed the ones we are going to deal with, that is the arithmetic, geometric, and the quadratic. So today we are moving on to look at the geometric sequences and series. Now, a geometric sequence is a sequence of numbers with a common ratio between consecutive terms. In our previous lesson, when we looked at arithmetic, we were having a common difference. That means the difference between the consecutive terms was the same. In this case, what will be the same will be the ratio between the consecutive terms. This is what you can also use to differentiate between arithmetic and geometric. We said it is important to know the difference. Now, the common ratio will be the constant amount by which consecutive terms are multiplied. So they are, just like we looked into arithmetic, there are important things we need. One, how do we find the nth term of a geometric series? Tn is equals to a r to the power n minus 1, where n is the nth term, a is the first term, just like we did with arithmetic, r is the common ratio that we just defined above right here. Now, having said this, we also need to understand how to find the sum of terms in a geometric series. We have two formulae for the sum of a geometric series. The choice depends on the value of the common ratio r. So, for you to be able to make a choice when a question asks you to find the sum of terms, you first need to find the value of r. Then after you do that, that will help you to choose one of the formulas given below. Sn is equals to a 1 minus r to the power n all over 1 minus r if the common ratio r is less than 1. Now, if it is greater than 1, Sn is equals to a open bracket r to the power n minus 1 over r minus 1. The difference is on switching the terms here. That is the difference. Now, and that is determined by the value of r that you get, the common ratio. Now, Sn is representing the sum of n terms, a is representing the first term, r the common ratio. Now, since this is a fraction, we need to be careful of what we call undefined fraction. An undefined fraction exists in a case where the denominator becomes 0. So this is why we have this red important statement here which says, note that the denominator in both cases must never be 0. We must avoid having a denominator that is 0 that will cause our formula to be undefined. So r must never be 1. If r becomes 1 here, you end up having 1 minus 1, or in this case also 1 minus 1. That will cause the denominator to be 0. That's what we are avoiding. That's why we are restricting the value of r at this point. Now, it means whenever you are dealing with geometric, your calculations must, or will not or should not give you a value of r that is equals to 1, because it causes that undefined. Now, with arithmetic at this point, we would have said we are done and we moved to the example. But geometric series has further things that we need to understand. That is the sum to infinity for a geometric series. So the sum to infinity is given by a over 1 minus r, for r is between minus 1 and 1. So the sum to infinity is only found when you are dealing with the geometric series. We never mentioned this when we looked at arithmetic. Now, this is the second thing that can help you identify whether the question is giving you geometric or arithmetic. If you happen to scroll in an exam down the questions and see them defining or stating anything that has to do with the sum to infinity, that alone is an indication that you are dealing with a geometric, not an arithmetic, because with arithmetic we never look at the sum to infinity. Now, there is a condition for you to be able to calculate the sum to infinity. The value of r that you calculate must be between minus 1 and 1. And remember, the end values are not included. That's why we have strictly less than, strictly greater than here, and strictly less than. Why? Because if r is 1, we get back to this case where we have an undefined situation. So that is why we have this restriction as well. So this marks exactly when do we calculate the sum to infinity. It is only asked when r is between minus 1 and 1, where S infinity is the sum to infinity of a geometric, A is the first term, and R is the common ratio. There is also another thing, a convergence of an infinite geometric series. A geometric series is said to converge if and only if R is between minus 1 and 1. So in exams, once you see them asking you about the sum to infinity, it means your R that you should have calculated or that you might have calculated is supposed to be minus 1 and 1. Otherwise, they cannot ask you something like this if the given series does not satisfy this condition. That's number 1. Number 2, there will be questions that ask you whether a series converges or not. What you need to identify is the value of R, whether it lies between minus 1 and 1. Now, having said all this, let's see what comes next. Okay, we now need to see how they ask you in the exam. With an example here, DBE paper 1 2015, question number 2. The following geometric series, here we are in luck. The question specified the type of a sequence that we are dealing with. The geometric sequence is given by 10, 5, 2.5, 1.5, 1.25. Now this is a sequence, not a series. Why? Because the terms are just listed separated by semicolon. We talked about this. Now, so to get the answers, the first question was calculate the value of the fifth term T5 of the series. Now this language right here helps you to identify the formula that you are to use. Remember, we have formulas for calculating the nth term, sum of n terms, and in this case sum to infinity, those things. So the wording that is used in a question helps you or should somehow direct you to pick the right formula. In this case, we are dealing with an nth term. So what you need to identify is the data that is provided. I am given the first term and the common ratio. Okay, here's how you calculate the common ratio. It is the next term divided by the preceding term. In this case, 5 divided by 10. That's how you get 5 over 10, which is this half. Or 2.5 divided by 5, still you get half. Or 1.5 divided by 2.5, that's how you still get half. Remember, it's common ratio. Now, having done this, we have identified that the formula we need is Tn for calculating the nth term. Tn is equals to AR to the power n minus 1. Make it a habit to lay your things in this way. It will help you identify what are you looking for, what is provided, and where can I substitute the data that I have. So having done this, we have A as the first term, it goes here, and my R is a fraction, that's 1 over 2. Then everything in bracket raised to the power 5 minus 1. Remember, n is 5. This question said fifth term, and we discussed and say n represents the nth term that you'll be looking for. So now we are looking for the fifth term, so my n is 5. Now having done the substitution, 5 minus 1 gives you this 4. Then after this, everything that is under this bracket, this gets us back to the simple lower grade maths of dealing with exponents. Now this means 1 to the power 4 as well, and 2 to the power of 4. A calculator can help you with this and get you directly to 5 over 8, which is equivalent to 0.625. So that's the idea, was on understanding it's a geometric and we are looking for an nth term, the provided data, the formula, then there is substitution. All this was going to help you to get to the required solution. Now continuing with the questions, we have to determine the nth term Tn in terms of n. We are still dealing with the nth term, so we are to this formula, and here they did not give us how many terms, so n is remaining. So where there is n, we still have our n. So A we substitute and our R is known as half, but n remains as required by the question. When a question says in terms of n, it means n is remaining as part of your solution. That's exactly it. Now 2.3, explain why the infinite series 10 plus 5 plus 2.5 plus 1.25 converges. Now once they mentioned series, we are now seeing we are still dealing with the same question. Yes, but here we were given a sequence. When they mentioned series, they started having a plus between the terms. That is exactly what we gave in the first lessons. Now, why does it converge? The real question is, when do we even say that an infinite geometric series converges? This is exactly what we discussed. We know that for a geometric series to converge, the value of r must be between -1 and 1. Earlier, we calculated our r at the top here and found that r is equals to half, and half surely is between -1 and 1. So, having seen this, we can conclude, since r is equals to half and half is between -1 and 1, then the sequence converges. I lost something here. Then the sequence converges. That's why. So it is in understanding when do we even say it converges. That is what I used. Then question number 2 here, 2.4. Determine sum to infinity minus sum of n terms in the form a b to the power n, where Sn is the sum of the first n terms of the sequence, and you are given 4 marks for that. So the first thing to do, what does this mean? Sum to infinity minus Sn. So sum to infinity minus Sn is equals to, we know the formula for calculating the sum to infinity is a over 1 minus r. We saw it in the previous when I just explained earlier. Now on this one, on calculating the sum of n terms, this is where we said the choice depends on your value of r. Our r is half, and half is less than 1. So the formula to choose is this one, 1. So the formula to choose is this, the one that takes r is less than 1. It is right here, a 1 minus r to the power n. That is what helped me make a choice on this one. Now everything else now comes to substituting what we are provided. And remember, we are given a format that we should leave our answer into. So my a is 10, my r is half, I substituted. My a is 10, my r is half. That is exactly what you are seeing here. I substituted all those. Now the next step was to simplify, moving towards the format that they wanted my solution to be in. Having said that, if you are to punch this in a calculator, or to those who are able to use their heads, this is 10 over half, which is the same as 2 by 10, which is 20. Or you can just punch, those with Casio, you can punch this beautifully in your calculator without any problems. You will get 20 for this part. And also here there is a little bit of arithmetic that happened, algebra that I did here. 1 minus half, you will get half. Now 10, open bracket, this term over half is just the same as 10 over half, then multiplied by everything that is inside. That is exactly what I did. So 10 divided by half that you get here, you will get 20. Open bracket, what remains in the bracket is this one, which is this, half, which is this, and everything to the power of n. Please, neatness is also important when you are dealing with this. If you write your work unclear, even yourself, you end up making unnecessary mistakes, losing marks. Now, having done this, 20, I can expand this 20, I can multiply everything inside here by this 20 to simplify. Remember, I know my format of the solution should be this. So having done this is 20, my negative 20 by 1, that's negative 20. Negative times negative, you get positive 20, but you cannot multiply 20 into this because this is still raised to another power n. Hence, I did not divide here to say I get 10. No. You have to remain with 20 here, open bracket, half, then raised to the power of n. Now 20 minus 20, this will give you 0. So your final answer will just be 20, open bracket, 1 over 2, then close, then everything to the power n. To check if you have reached the final, our solution is supposed to be a, b to the power n. So in this case, this is my a, this is my b, and this is my n. So ladies and gentlemen, at this point, we can say we have answered the questions on geometric, specifically this question number 2 from 2015. The idea is on understanding the steps that we discussed. When do we say geometric series converges? How do I attempt and conclude on questions like that? What does this mean? It's not a matter of guessing. you need to know the meaning of this. That's why we define the terms whenever we are giving the formulas. Now, having done this, we will look next into the sigma notation. I mentioned it earlier, but we said we'll look into it. So we have done the arithmetic and the geometric. So guys, wait for the next video. I hope you'll be going through this and finding more questions. We will discuss more of the past exam paper questions later, but for now it is just the theory with a few examples. I thank you so much. I hope you subscribe and also contact me for more and also assist me in making this better. Thank you so much. Enjoy your lessons.